Hi everyone. We are doing statistics. This is our first topic in statistics. We are not going to go into the definitions of statistics, what is statistics and all those stuff. We assume you know them at this level. So what we have here on the board are variables or data that we are going to be working with. So it's better we define these variables or this data so that when we come across them later on, you know what they are. You have what we call a quantitative variable or quantitative data. Quantitative variables / data, they come in two types. They can either be a discrete variable or discrete data, or a continuous variable or a continuous data. We shall define discrete and continuous. But quantitative variable simply means these are variables that have something to do with numbers. They are countable. You can assign a number to them. 1, 2, 3, 4, 5, or 2.5, something like that. Something that is related to a number. You can be able to assign a number to a quantitative variable or quantitative data. On the other hand, a qualitative data, from the word quality, this is something that you cannot be able to assign a number to it. It's just quality, something you can see. You say, oh, this is good, this is bad. It's quality there. Or you say, oh, this car is nice, or this person is beautiful. These are all qualities. Or this person's color is brown, is red, is green. The quality of the hair, the color of the hair. So color of the hair. These are all qualities. So they fall under qualitative variables or qualitative data. So now, I didn't give example of a quantitative variable or quantitative data because we have two types of them. They fall into two categories. We have the discrete. Discrete variable is a variable that can take any value. A discrete variable. Mind you, we've already mentioned that discrete variable and continuous variables, they come from quantitative. They are associated with number. So the discrete one, they can take a specific number within a range. Within the range you are given, they take a specific number. For example, if you are in a household, people in a household, you can't say there are 3.5 people in the household. It's not just possible. Somebody to be half or 3.57 people, girls in this class. That's not possible. A discrete takes specific numbers. You can say the number of boys in this classroom is 5. The population of this country, 10 million people. So these values are discrete values. While continuous variables, they can take any value within a range. What that means, they can have decimal numbers. Like, for example, time. If you are measuring time in seconds, you can say 2.5 seconds, 2.03 seconds, 2.2534 seconds. You can say that these are continuous. So after explaining these variables and data we have here, we have two problems here. We are going to solve this problem side by side, which means we are going to do both of them almost at the same time. They look different, but the method is very is closely related, and I want you to see the different approach when you have this kind of problems, because mostly you're going to have something like this group data. The first problem here says the length of the 4 wings of a random sample of adult butterflies in millimeters is given here. This is the length of the 4 wings butterfly. These are measured in millimeters. 2 butterflies in that sample. They collected 2 butterflies. When they measure their length, it's between 30 to 31 millimeters. You have 2. The other category, 32 to 33, you have 25 butterflies. The other category, 34 to 36, you have 30 butterflies. 37 to 39, you can just make it up. You have 45 butterflies. Yeah? This is the problem number 1. Problem number 2 says the distribution of the masses of 2-month-old lambs is shown in the grouped frequency table. This is now a frequency table, and it's grouped. That one too is grouped. But the difference between these two is that this one here has an equality, 2 equality signs. This group is just from between 30 and 31, you have 2 butterflies. 32, 33, you have this, so on and so forth. But here you are given that the masses is talking about masses. Yeah, the masses of 2-month-old lambs. 1.2 kilogram and 1.3 kilogram have 8. That the masses of lambs that are greater than or equal to 1.2 but less than 1.3 is 8. Just concentrate on the inequality sign so that you see the difference of the 2 problems. So what are we asked to calculate? We are asked to write down the class boundaries for the 3rd group. Class boundaries. I want to erase this top so I can leave it again. So that we can walk through here. This was number 1. And here was the length. So let's calculate the class boundary of this one. Class boundary. This is a class. 30 to 31 is one class. 32 to 33 is another class. 34 to 30 is another class. So they ask us to calculate the class boundaries for the 3rd group. So let's look at this 3rd group here. 3rd group says 34, 36. 34 to 36. If you want to calculate the class boundary of this group, the 3rd group for this one here, what do? You reduce this by 0.5, by half, and you add this by 1/2. So here, now you are going to have, if you take, let me do one that is simple. Let's start with this one. 30, 31. Class boundary of 30 to 31. This is simple. So if you add, you reduce here by 0.5, 30 points. $30.5 31.5. What are you going to get? Let me do correct. Let me do this one. Second one, 32 to 33. I want something that you can easily see. If you reduce this by 1/2, you're going to get 31.5 to this one now is going to be 33. You add here, here you reduce, here you add 33.5. This is what you do. You subtract from this first one and you add to the last one. You subtract, you get 0.5 here, 31.5 here, you get 33.5. So we added, we subtracted here. This is what you do. The first one, you subtract. The second one, you add. And you do the same thing. Anyone they ask you to find the class boundary for, this is what you do. If they ask you to find the class boundary for this, you do the same thing. They ask you the class boundary, you reduce this 0.5, you add this 0.5. That's all you do. But when you come here, that's the difference I want you to watch out for. Because it has an equality. 1.2 m, the mass is equal to or greater than 1.2, but less than 1.3, and number of lamps 8, or frequency 8. So if they ask you to find the class boundary of any of these ones here, you don't need to change. You don't need to change anything. Find the class boundary of this first one, 1.2 less than or equal to m less than 1.3. Class boundary here, the class boundary here is 1.2 to 1.3. This is the class boundary for this one. Similarly, this one, class boundary 1.2 to 1.3. This one here, class boundary 1.3 to 1.4. This one, 1.4 to 1.5. And finally, this one here, 1.5 to 1.6. This is the class boundary. Because of this inequality sign, you just write down what you see. But here, you calculate. You minus 0.5, add 0.5. So, first question answered. The next one say, work out the midpoint of the second group. Or work out the midpoint of the first group, what we've already started. So here at the midpoint, now midpoint, that was the class boundary. Midpoint of first group, of this group. First group. This is now equal to midpoint. I'll just say MP, midpoint. This is equal to 1/2 and you add these two. 31.5 plus 33.5. The midpoint most times is not even in the data. The number, the answer you get, in most cases, that number you won't find it in the data that you are given. So you calculate for midpoint. So here, 31.5, 33.5, this is 0, 4, 5, 6. So this is 65.0. This is midpoint, and if you divide this by 2, you get 32.5. So, am I right? 32.5, yeah? Yes, that's what you get as your midpoint. Do we have that? No. Most times midpoints, you don't get it in the data you are given. So here, the midpoints is the same thing here. You just add any two and you divide. You just add this range you are given, 1.2 plus 1.3, you divide by 2. If you are asked to find the midpoint of this class, 1.3 plus 1.4, you divide by 2. This one, if you're asked to, 1.4 plus 1.5, you divide by 2. That's the midpoint. But for this one, you see the midpoint because you calculate with the class boundary. What you got earlier on the class boundary, which is 31.5 and 33.5, these are the two you add to get your midpoint. So now, let's work out the class width. Work out the class width. The width now. Class width. Class width. So class width, that is what did we get here was the class boundary here was 31.5, was it? So yeah, for this one 31.5 to 33.5. For this one, we are looking at this. Yeah, calculate the class boundary for this. We calculated the midpoint for this, and now we are calculating the class width. Here, the class width, you subtract the upper boundary from the lower boundary. That is 33.5 minus 31.5. And what do you get? This is 0. 3 minus 1 is 2. 3 minus 3 is this. So the class width is 2 millimeters. 2 millimeters for this one. Why you need the class width? Well, later on, we'll start to plot graphs like histograms and bar chart, and then we'll know what these values we are talking about, what they mean. For now, they might not make sense to you, but the moment we start to plot in statistics, you do a lot of plotting graphs. So then you will know what all this boundary class we are talking about, this class width, this midpoints, then you will know what they mean. For now, they might not make sense to you. So here, if they ask you to find the class width of anyone here, you just again do direct subtraction. If this one here, for this top one, class width is 1.3 minus 1.2. So here you are subtracting here, the top from the bottom, or the higher from the lower. So 3 minus 2 is 1. 1 minus 1 is 0. So you get 0 points. You get like 1 kilogram. 1 kilogram class width for this one. That's what you get. So that is it for today. We'll advance next time, solve more problems. Thank you for watching. Bye bye.